Okay girls, we're starting a new chapter today. It's called Pictorial Projection. In Pictorial Projection, we are going to study in the next couple of weeks 2 different types of 3D drawing, so 3-dimensional. So by the end of this, you should be able to represent 2D shapes into a 3D manner. Okay, you should be able to recognize the different forms of pictorial drawing. You should be able to draw pictorial views using oblique drawing, and you should be able to draw pictorial views using isometric drawing. Okay, orthographic projection was already studied. Okay, so at this stage you know what an elevation, an end elevation and a plan are. Now I'm going to give you these views and you're going to have to draw the 3D. Okay, so before I gave you the likes of a 3D drawing, I need to draw the 2D views. Now I'm going to give you the 2D views and produce a 3D drawing. So in technical graphics, you need to be able to work from 2D to 3D and from 3D back to 2D. So I have been giving you 3D drawings and we've been doing developments where you opened out the 3D shape, and we've also looked at what the principal views are, looking at the front of it, the side of it and the top of it. Okay, so the 2D drawing can be represented in a number of 3D forms. We're going to look at oblique, isometric, and in second year, you're going to look at axonometric. Okay, so it's a little bit more complicated. You can see it there. Looking at the 3 different types. So this is oblique, this is isometric, and this is axonometric. You should be able to kind of come up with what is the most realistic looking. Okay, and you can kind of see that the axonometric and isometric look more realistic than this one. This one looks kind of funny. Now, oblique is actually the easiest type of 3D drawing you can actually do. I am just going to talk over here now about oblique drawing. Okay, oblique drawing is one of the simplest forms to create a pictorial drawing. In oblique drawing, the front of the surface is the same as the orthographic, and it's drawn to full size. The side is projected back at 45 degrees. So basically, you draw the front of the object, and you bring all the points back at 45 degrees, and the depth remains the same. As a result, more information can be obtained from a single 3D drawing from a 2D drawing, making 3D drawings more beneficial. A key word, so oblique, means having a sloping direction, angle or position, and in oblique that angle is 45 degrees. In class now, okay, I'm going to do this question. Okay, and you have this question as well. So in oblique, you're going to draw the front of it, and every point is going to be brought back at 45 degrees. Okay, so I'm going to start this question now. So we're drawing the front of it and then bringing every point back at 45 degrees. This will fit perfectly on an A4 page. I appreciate that I have an A3 page. I'm going to keep it to the left hand side so I can maybe fit 2 questions on this. Okay, it doesn't need to go on the top or bottom, it can go in the middle. Okay, so I'm starting off with my ground line like I've always done. And I'm going to step off the measurements. It's 190 wide. Now my line wasn't long enough. So it's 190 wide. And I'm measuring in a distance of 110, 150, that's 20 in. The legs are 20. I need 110 then. 20 for the thickness of the leg and a final 20 at the end. Okay, each of these can be drawn vertically up. The overall height is actually only 50 tall. Okay, and it's divided up into 30 and 20. Bring these across. Okay, I now have my grid as such, and I can start drawing this table in heavy. And then working from left to right, as you've seen loads and loads of times already. Okay, so I've basically drawn the elevation or the front of the object. To make it 3D, at every corner, I'm going to transfer it back at 45 degrees. It doesn't matter if I go to the left hand side or the right hand side, as long as you're consistent that every point goes to the left or every point goes to the right. Because I've loads of space to the right hand side, I'm going to bring every corner back at 45 degrees to the right hand side. I'm starting at the top left. So back at 45 degrees. Back at 45 degrees. Back at 45 degrees. Now, this one here, if I draw it, it's going to cut into the table, so I won't be able to see it, so I'm going to ignore it. Next one, back at 45 degrees. This one the same. It's going to cut into the table, and this one is going to cut into the table, so I can't draw it. Over underneath the table, that can go back. This one is going to cut into the table, can't draw it. This one is going to cut into the table, can't draw it. This one is going to cut into the table, can't draw it. And this one is going to cut into the table, so I can't draw it. So you can kind of see I have 1, 2, 3, 4, 5 different lines. And I'm going to go back to the question now and just zoom in for a second. When you look at the question, okay, we've been given the elevation and plan. I've drawn the elevation perfectly. And the top of the table is 55 long or wide. So each of those lines needs to be 55. Now all I'm going to do is measure 55 once. That should be enough. You could do it on every single line if you wanted. But we'll do it the once and see what needs to happen. So on this edge, it has to come across and touch on the other side. It needs to be parallel to the front of the table, so it's going to be a horizontal line. So just, you can draw that horizontal line in. I'm going to zoom out now so you can kind of see it a little bit better. And see where it touches on the line. Okay, so it stopped right there. Then I need a parallel line to the side of the table, which is going to be a vertical line. Okay, so I'm going to draw the vertical line in. Okay, and you can see.
Would Megan O'Reilly come to the office to collect a book? Megan O'Reilly.
Okay, apologies for the interruption there. I did a parallel line to the vertical line and I saw where it stopped. I now just have kind of 2 more lines left, and they're for the bottom. Now the issue I have is I can't really see the line very well, so I can measure the 55 degrees again. Okay, and that's going to need to be parallel to the line it came from, which is going to be a vertical line. And then, I have to do a 55 degrees on the other side. And if I try and measure 55, I can't see it. So I know that that line continues on and goes underneath the table. I can now get my heavy pencil and pop in all of the lines in heavy as they need to be. I'm going to start with the 45 degree lines, the 5 of them that I need to do. So this one needs to go as far as here. In each case. So if you've measured the 55, go that far. If the 55 won't fit, you just draw the line until it touches the object and you stop. Now I'm going to do the horizontal lines. There's only one. And now the 2 vertical lines. Until it touches the object. Okay, so this is a bench. It was 190 wide, it was 50 tall, we were given the measurements on it. At each of the corners that we could see, we brought them back at 45 degrees. Now you don't need to write that in, I'm just showing you that every point went back at 45 degrees. The thickness you take from the actual question. Okay, so I got that measurement from the question, it was 55 wide, we've been given a plan and elevation, and that's where it's coming from. Okay, so this is oblique drawing. Do a title first. oblique drawing. And basically every point comes back at 45 degrees. Oblique means having a sloping direction, angle or position. You are going to join me in class live now once you've completed this. And I'm going to give you 2 more questions. One of them I'll do with you and the other question you'll do on your own. And that will complete the class for today. See you live.